In this lecture, let's understand input-output operands and constraint string. Each input and output operand is described by a constraint string followed by a C expression in parentheses. Basically, this is a procedure how we mix the ARM instruction and the C variable. You have to use a syntax something similar to this. First, you have to use a constraint string followed by a C expression in the parentheses. And the constraint string is collection of two more things, that is constraint character plus constraint modifier. So I know this is confusing and it doesn't make any sense in describing these things unless we see one example. That's the best way to understand. For that, let me explain this through an example. Let's say your objective is to move the content of a C variable val to an ARM register or not. How do you do this? By using the inline assembly statement. Here you should first identify what exactly you are going to do, and you have to select one instruction from the ARM instruction set. This is basically data copy. I want to copy the value of C variable into a register or not. So a data copy, I can use the instruction move or load maybe, but move is more suitable here. I would select move, and after that, what is a source? Source is a C variable val that we can call it as a source. Once you fix the instruction, now you have to understand the operands of that instruction. Let's understand the move instruction that you can find in general data processing instructions. Move is right here. For the move instruction, you have to mention two things here. One is the destination register, and this is the operand. Data copy happens like this, operand to RD, destination register. That means I can say this is a source and this is a destination. That's why here in this statement, if we select the instruction move, then destination would be R0 and source would be a C variable, that is val. This is how the inline assembly looks like. First of all, you must mention the code section. This is a code section, that is the ARM instruction move, and we have used the destination R0. That's correct. After that, there is no output operand, isn't it? We don't have any output operand, but we have input operand. C variable val is an input operand, and this is one input operand. Just check the way the input operand is written. Let me explain that right here. Just take a look how the input operand is written. First of all, this is a constraint string. Constraint string which should be written in double quotes. Now the constraint string is collection of two things. One is constraint character plus constraint modifier. Here there is no constraint modifier. You only see constraint character R. After that, in the parentheses, you have to mention the C variable name, that is val. In the code section, this refers to the first operand. This is used for operand indexing. Here %0 refers to the first operand. This is the first operand. If you use %1, then that refers to the next operand, if it is there, like that. In our case, we don't have any output operand. That's why you have to leave that space empty here. And we have only one input operand. That's why compiler will replace this by the first operand, which it finds in either output operand list or in input operand list. That's how you should write this. And now you may be having doubt regarding this. What is the use of this? Let me explain that. when we do one exercise. Here is a table of constraint characters and constraint modifier. I will come to this little later. Let's do the same exercise. Move the content of C variable val into ARM register R0. Let me get into the IDE and let me remove all these codes or comment this out. Let me create one C variable int val is equal to, let's say, 50. I want to move this value into R0. ASM volatile. So the instruction I am going to use move. The destination is R0 and the input is this variable. I would end this code section with %0. And after that, colon, because I don't have any output operands, I have to leave that space empty. This is an input operand list. Input operand is val, variable name val. Now let's end this statement. Here, this operand is collection of constraint string plus expression. This is the expression. Now constraint string you have to write in double quotes. The constraint string in this case is R. Let's understand what exactly is the meaning of R. The meaning of R is, you can get from this table, R actually tells the compiler to use general registers for the instructions which it is going to generate. Let's see that practically. Let me just compile this and execute this code. It builds well. By the way, you can see that I didn't give one more colon here because the clubber list is empty. We are not using that field. That's why you can give colon here, or you need not to give any colon. You can omit that, no problem. But you cannot omit this colon. If you omit this colon, what happens? This will be treated as output operand. That's not true. So that's why I have to give colon here. Let me just build this project. After you build the project, what you do is right-click, go to the properties and go to the location. Here it is. Go inside the project, go to debug and open the list file. Here you will get the disassembly of the project. Go to the main function. Where is the main function? Here is the main function. Here you can see that for this inline assembly statement, it generated two instructions. What it did was first get the data from this variable to a register R3, and after that copy the content of R3 to R0. Because the variable what we created is in the stack memory, it is in the RAM. That's why this is a memory load. A variable data is loaded to R3 and this is a data copy. That's the beauty of using inline assembly code. If you don't use this inline assembly code, then you have to write this yourself. Instead of writing this is much easier, isn't it? Why this R is required here? This constraint string R tells the compiler to use registers for the data manipulation. What are the other constraint characters? Let's say I use I. Then it's the immediate value. Let's see that. Instead of R, I give I. Build the project. It doesn't take that. Yeah, so it doesn't match. Here you can give value. Here I have given a value, an immediate value. Now you can see that the instruction is modified. And you can see that for this field, no register is used. It's an immediate value. In the earlier case, for this field, a register was used. One register was utilized. But in this case, it is replaced by the immediate value. What if I use R here? Can I use R here? Let's see. Build the project. Yes, it takes. Let's analyze. Now you see here, there are two instructions, and for this field, register is used. Move instruction, move instruction. For this field, register is used. That's what being imposed by the constraint character. Here, what happened was 80. This immediate value is moved to R3, and R3 is used as the source for this instruction. That's why this constraint character controls whether a register should be used or whether immediate value should be used with the instruction. I hope you understand that. Let's use val here and let's build this project. Debug this. Let's see what happens. Let me do step over and look at the value of R dot. R naught now holds 32. That is hex equivalent of 50. That's how you move the content of a C variable into an ARM register. Let's move forward. Let me take up this example. In the next lecture, let's talk about output operand and try to do this exercise. Move the content of control register to a C variable control reg. And I'll see you in the next lecture.